Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we'll be doing a topic video, a special topic video that's going to save you a lot of time in your exam, in your SAC for your calculus chapters, okay? So this is going to be solving differential equations using definite integrals. There's a specific type of question that may come up, actually not may, that will come up in the exam, and you want to make sure that you know this technique, this shortcut, because it's going to save you, I'm pretty sure, at least 2 minutes worth of work. Okay, so that's 2 minutes is a huge amount of time. You can use that to answer 2 multiple choice, maybe 3 even. Okay, so let's have a go. Let's have a look at this type of question. Then I'll show you the traditional way and I'll show you the shortcut way. Right, so this type of question is to give you a differential equation. You're going to start off with dy dx equals to, some kind of function. We'll call that x for now. And then they're going to give you initial condition. So given that y equals 0 and x equals 0, find a specific y value when x equals to 1. Unlike your typical differential equation question where they ask you to find the solution, this question right here, usually this question comes after that, the find the solution question, is find the y value, the specific y value when x equals to 1. So they're actually not asking you for a solution. They're not asking you for an equation. They're asking you for a specific y value. Right, I'll show you the traditional way and then I'll show you the shortcut way. So how would you go about doing these questions? Well, typically, you're given a differential equation, you antiderive that to get the solution. So that means y equals to antidiff of x in terms of x, and then you'll end up with half x squared plus c. And then of course you solve for c, and to solve for c you sub in a value which is the coordinates they give you, x equals 0, y equals 0, and then you solve for c. And in this case, c just happens to also be 0. So therefore, y equals to half x squared plus 0, or just half x squared. Okay, now the next part is you sub in the value that they want. So x equals to 1, because you want to find the y value when x equals 1, right? So you sub that in, y equals to half times by 1 square. So therefore, final answer, y equals to half. So that's the traditional way. The amount of steps here is 1, 2, 3, 4, 5, 6, 7, 8. Roughly 8 steps if it's this easy. This is the easy example you can get. That's why this kind of looks, quite easy. But I'll show you the shortcut that's gonna pretty much be a 3-step process, and it's gonna save you a lot of time. Okay. To do that, I'm gonna show you the proof for it, and then I'll show you the shortcut. Right. So the proof, I'll do it on the right column over here. Okay. We're gonna have y dy dx. Actually, we're gonna start off with dy dx equals to fx. Okay, dy dx equals to fx. So this is a general thing. When you're proving, really, I'm just proving a general formula to show that it works all the time, this shortcut right here. So if you want to solve for y, the solution is y equals to the antidiff of this, and I'll call that fx. Okay, so big F meaning the antiderivative of whatever function you have here, and of course you always have a plus c. So that's what we get here, y equals to fx plus c. And then we sub in the initial value that they give us. So in this case, 0, 0. But to be general, I'll just say I sub in AD, okay? I'm going to sub in a point AD, and then therefore y equals D, and then of course x equals to A, and then we have the plus C. What we do here is we find the C. Let's move the FA to the other side. So this is just a number, D minus f of A. And our function would therefore be y equals to f of x, so the big F of x, plus c we know is d minus f of a. Okay, so I'm just doing the same thing here as what we've done here, but general form, right? And then of course we want to find x, x equals to another value, right? We want to find y when x equals to another value, and let's say x equals to b. So you will sub in b into your x fx over here, and you get fb minus fa. I'm going to bring the fa to the left side because the magic comes after this. Okay, so y equals to fb minus fa plus d. Okay, so this is how the shortcut came about. If you look at this section right here, fb minus fa, another way, so what you actually can realize is this is just the same way as writing this. So y equals to the antiderivative of fx, so fx small f is the gradient that was given to us, the first derivative. And then if you want to get b and a, or b minus a, well, if you put b on your upper terminals and you have a on your lower terminals, if you antiderive this is actually the same result. This part right here, this integrand gives you, this definite integral gives you these two terms, fb minus fa. And then the plus d is, well, it's just plus d. That's the point they give us, right? So this one right here is actually the shortcut. So we're gonna apply that to our question, okay? So this is a formula that you guys want to memorize. It's gonna be the formula that's gonna save you a lot of time. So make sure you know this. Put it inside your, the book, your bound reference, because it's a really good one. Okay, so it's called solving differential equations using definite integrals. So let's apply it to our question over here. It's gonna be like a 3-step process. Trust me, it's really short. Y, okay, apply our formula is equals to the antidiff f of x. What is f of x? Well, that's the first derivative, right? So that's just x. We anti-derive in terms of x. Okay, now only thing that you're missing is your upper lower terminals and the plus d. So what is a? A was the value over here that was given to us, the initial condition, right? So a was the initial condition of the x value. So that's 0. So actually, to make it really simple, I'll put a as x0, and then b was the x value right here. So b right here is the x value that was given to us to find the y value. So I'll call that x1, okay? x1, that's the one we want to find. So y1 is the y value that we want to find. x1 was the x value given to us to find that y1. Okay, and then we have the plus d. What is d? Well, d is just the y coordinate of the x0, right? So we'll call that y0. Okay, that's pretty much the formula. If you know this formula, or you know this formula right here, it's the same thing, then you're going to save so much time. So let's apply it. y1 equals to x1. What was that? That was 1. What was x0? Well, x0 was 0. That was the initial condition. X dx plus y0. y0 was the initial y value given to us as well. That's plus 0. And then y1 is pretty much, you just anti-derive this. You get half x squared, and then sub in 1, sub in 0, plus 0 is just, well, plus 0. You can ignore it if you want. And then that is equals to, sub in 1, we get half x squared, so that's just half 1 squared, which is half, and then minus 0, which is equals to half. So this is actually a 3-step process. It's very short. The only thing you need to know is obviously the formula. This is not in your formula sheet, so that's why I recommend you put your bound reference, and if just in case in Tech 3 you want to memorize that as well, okay? So this is the shortcut, okay guys? That's the formula. Actually, it's probably better to use this formula right here, so apologies for that. This is the king, okay? This is the shortcut that you want to know. y1 equals to the antidiff x1 upper terminal, x0 lower terminal of x in terms of x plus y0. So that's pretty much what I want to show you guys in this topic video. It's a good shortcut. It's going to save you a lot of amount of time. But aside from that, guys, if you did find this video useful, make sure you leave a thumbs up and a comment if you want. But aside from that, thanks for watching, and I'll see you in the next video.